Types of subqueries. There are a number of distinct subquery types. Let's look at the first one, a single row subquery. A single row subquery has to return a single row, basically a single element. The query calling the subquery requires that single row. For instance, you couldn't say where category ID is equal to multiple rows because it simply wouldn't make sense. You would actually get an error if this query produced more than a single row. Let's take a look at an example. First of all, let's set our columns, just to make sure the information doesn't wander off the screen. Now here's an interesting query and subquery. This subquery will produce more than a single row, so let's show the error. And here's the response. Select category ID from category produces all the rows in the category table. We cannot say is one value equal to 34 different values. It simply doesn't make sense. Let's take a look at the query that we had on the screen just now and show it functioning. Here we say select category ID from category where name is comedy. So let's run this query, and we find all the rows in the show table that have category ID where the name is comedy and the category ID is 6. 30 rows have the category ID value 6. Let's prove that. Let's go and count the entries in the show table where the category ID is equal to 6. We have 30 rows. Now let's run a sensible query with a single row return subquery for all categories which are comedy. And as you can see, these are all comedy venues with comedy acts. The next type of subquery is a multiple row return subquery. In this case, we would need to check from the calling query into the subquery for membership as opposed to an exact match. So in this case, the subquery can return many rows. So let's take a look at a multiple row returning subquery. In this case, we're selecting from the category where the category ID in the category table exists in the show table. We can prove that by simply counting the groups of categories within the show table. We have 7 different category groups in the show table. Another type of subquery is a multiple column subquery. What the subquery does is actually select more than one column. Obviously we need to check more than one column against the subquery by checking more than one column in the calling query against the multiple columns produced by the subquery. Here's an example. Here's a list of rows, or should we say venues and acts, which have tickets in the ticket table. This query here will return multiple columns from the ticket table. Another type of subquery, or two types of subqueries, are actually the regular and correlated subqueries. A regular or normal or standard subquery is a subquery where there is no relationship between the calling query and the subquery. An interesting point to note about in is that it should generally be used for literal values, since in is constructed first within the subquery, which in this case this is an expression list, and then the whole result of the subquery or expression is applied to the calling query. Let's run that regular subquery. We get 10 rows from the category table whose category ID is in that set of numbers, 1 to 10. The correlated subquery. In the correlated subquery, there is a relationship between the calling query and the subquery. This relationship is established based on one or more tables in the calling query using the exists clause, passing a result from the calling query down into the subquery where the subquery table, in this case category ID, is matched against the category ID from the calling table. This is very important to remember. The exist clause is much faster than in this example. Why? Firstly, as you remember, I said that in will pre-execute this SQL statement or this expression within this subset, subquery or expression. Exists will actually pass an index value, if one exists on the category ID, which is what's used here, down into the subquery. So you'll match indexes between the calling query and the subquery. As I said, in doesn't do this because in executes the entire subquery first. In is very quick for literal values. Don't always use indexes. It is sometimes faster to read a whole table. That's tuning. But the difference between in and exists applies in this case, because in will use indexes. If your files are small, you don't necessarily need to use indexes. It could be faster to simply read the table and moreover the whole table rather than read the index and the table. However, when the tables are larger, you can use exists and it will perform more effectively because it will match indexes between the calling query and the subquery. Ultimately, the subquery matches between, in this case, the category and the category IDs between calling query and subquery.